Welcome back to Summarize Science. Today, we're looking at a fascinating problem. How can we teach an AI to understand the incredibly detailed images our satellites take of Earth? A single satellite image can contain thousands of buildings, ships, or fields. Manually outlining every single one to train an AI is prohibitively expensive and time-consuming. This is a huge bottleneck for using AI in important fields like urban planning or environmental monitoring. Now, there's a powerful general-purpose AI called the Segment Anything Model, or SAM. It's great at outlining objects in everyday photos you might take with your phone. However, when you apply it directly to complex satellite imagery, it often struggles. As you can see in these examples, it can produce messy, overlapping masks where different objects bleed into one another. To solve this, researchers developed a new framework they call ReSAM. The main goal of ReSAM is to adapt the powerful SAM model to this new, difficult domain using only sparse point annotations, basically, just a few clicks on an object. The system works through a clever iterative process called the refine, requery, and reinforce loop. First, the AI takes the initial points and generates a rough, coarse outline of an object. This is the refine step. Next, it automatically draws a simple bounding box around its own rough guess. It then uses this new box as a much better prompt to ask itself, can I do a better job now? This is the requery step. It's essentially asking for a second opinion from itself, but with a better hint. Finally, the reinforce step makes sure the AI's understanding stays consistent across different views and iterations. This helps prevent the model from becoming overconfident in its own early mistakes and spiraling into error. So, how well does this self-prompting system work? The researchers tested ReSAM on 3 challenging remote sensing datasets for buildings and ships. The results in these tables show that ReSAM consistently outperforms the original SAM and other recent methods that also try to learn from limited information. You can really see the difference in these qualitative results. While other methods produce fragmented or inaccurate outlines, ReSAM's results are much cleaner and more closely match the ground truth. So, let's recap the key points. The ReSAM framework provides an efficient way to adapt powerful segmentation models to specialized domains like satellite imagery without needing expensive, dense labels. It achieves this with a smart self-improvement loop where it refines its masks, requeries itself with better, self-generated prompts, and reinforces learning to stay consistent. This work demonstrates a path towards creating highly accurate, large-scale land use maps much more efficiently. In the future, this could significantly speed up our ability to monitor deforestation, track urban growth, or manage agricultural resources, all by giving AI a smarter way to teach itself to see our world from above. Thanks for watching Summarize Science.